The planet was reclassified, not this one. This. Pluto was considered the ninth planet of the solar system for most of the 20th century. It was discovered in 1930 by Claude Tombaugh at Lowell Observatory. At the time, astronomers believed that something large must exist beyond Neptune to explain small deviations in Neptune motion. Pluto was thought to be that object. For decades, its status remained unquestioned. This changed once telescopes improved and new surveys began. In the early 2000s, astronomers started discovering many bodies in the region now known as the Kuiper belt. These bodies were icy, distant, and similar in size to Pluto. By 2005, the object named Eris was found to be slightly more massive than Pluto. Discovery forced astronomers to rethink the definition of a planet. If Pluto was to remain a planet, then Eris would need to be reclassified as one too. As a result, the International Astronomical Union introduced a formal definition of planet in 2006. The definition included three criteria. A planet must orbit the Sun. It must have enough mass for gravity to form it into a near spherical shape, and it must be the dominant body in its orbital neighborhood. That last requirement became the deciding factor for Pluto. It meets the first requirement. It travels around the Sun once every 248 Earth years. It meets the second requirement as well. It has enough mass for its own gravity to maintain a nearby spherical shape. But it does not mean the third requirement. Pluto shares its orbital zone with many Kuiper belt objects. It has not cleared its region of comparable bodies. Neptune, for example, has removed or controlled most objects near its orbit. Pluto has not. Because of this, Pluto was reclassified as a dwarf planet. Reclassification did not change Pluto's physical properties. Its size, orbit, atmosphere, and geological features remain the same. The change was purely about classification. The goal was to keep the terminology consistent with modern discoveries. Today, Pluto is considered the largest known dwarf planet in the solar system. It is smaller than Earth's moon. Its mass is only about 0.2% of Earth mass, and its density indicates a mixture of rock and various ices. These include nitrogen ice, methane ice, and carbon monoxide ice. The sunlight is faint but still enough to create slow cycles of freezing and sublimation on its surface. Its distance from the Sun varies from roughly 29.6 astronomical units at perihelion to about 49.3 at aphelion. The orbit is also tilted. The inclination is around 17 degrees. This tilt creates a three-dimensional separation between Pluto and Neptune, even when their projected paths seem to intersect. The eccentricity of Pluto's orbit is about 0.25. This means the orbit is far from circular. During perihelion, Pluto moves inside Neptune's orbital distance. Pluto is locked in what is called 3-2 mean motion resonance with Neptune. For every 3 orbits that Neptune completes, Pluto completes 2. The resonance maintains safe distances over millions of years. The resonance works because gravitational interactions between the two bodies adjust Pluto's orbit slightly over long time scales. If Pluto drifts a little faster than the exact 3-2 timing, Neptune's gravity slows it down. This keeps the pattern stable. The process repeats every orbital cycle. Another stabilizing factor is the position of Pluto's perihelion. Dwarf planet reaches perihelion when it is far above the orbital plane of Neptune. This happens because the argument of perihelion librates around a fixed region instead of rotating freely. This explains why some Kuiper belt orbits show chaotic behavior, while Pluto's orbit remains stable. The dwarf planet's semi-major axis varies only slightly. It stays close to 39.5 astronomical units. The orbital period varies if a few years from cycle to cycle but remains resonance close to 248 years. The resonance is strong enough to maintain this pattern over billions of years. Pluto also has a unique rotational and tidal characteristics due to its largest moon, Charon. Pluto and Charon are tidally locked to each other, just like Earth and the Moon. Pluto's atmosphere is thin but dynamic. It contains nitrogen as the dominant gas, with methane and carbon monoxide as trace components. As Pluto moves closer to the Sun, sunlight warms the surface enough to sublimate nitrogen ice. This creates a temporary atmosphere. As Pluto moves away from the Sun, the gas freezes again and falls back to the surface. New Horizons measured the thermal structure of this atmosphere during its flyby in 2015. New Horizons also observe surface units that hint at past geological processes on Pluto. Pluto's orbital characteristics are determined by gravitational forces, not atmospheric or surface processes. Pluto's current classification as a dwarf planet follows directly from this history. Its orbit reveals long-term gravitational structure of the distant solar system. Its resonance with Neptune demonstrates how orbital timing maintains order even where crossing paths appear possible. It is a stable member of a precise resonance and the structure of the Kuiper belt.